Good morning. Welcome back to our second term to cover our lesson, which is solving two equations of the first degree in two variables, graphically and algebraically. Our lesson today is lesson 1 in unit 1, algebra prep 3. Let's move to slide number 2. The equation x plus y equals 3 and 3x equals y minus 7. Also, we have y equal to x minus 1. All these equations are examples for the first degree equation in two variables. Each of them contains two variables, which is x and y. Each of these two variables is of first degree, which means that the index of each of them is 1. For example, with respect to the equation y equals 3 minus x, as x equals 2, so y equals 3 minus 2 equals 1. So 2 and 1 is a solution of the equation as we studied before in prep 2. As x equals 0, so y equals 3 minus 0 equals 3. So the ordered pair 0 with 3 is a solution for the equation. As x equals negative 3, so y equals 3 minus negative 3 equals 6. So negative 3 and 6 also is a solution for the equation. What I did, that I want to get some ordered pair to represent the equation. I want to get some ordered pair to represent the equation. So I suppose from me the values of x or y to get the other variable. Let's move to slide number 3. We can get an infinite number of ordered pair. Each of them represents a solution of the equation in R by R. So 2 and 1 solution for the equation. So we can represent 2 and 1 on the graph, like 2 and 1. I will move 2 steps in the x-axis, then going up 1 step. Also the point 0 and 3. Which means I will stand at 0 and moving up 3 steps. The point negative 3 and 6, I will move to the left on the x-axis 3 steps, then up on the y-axis 6 units. So I have negative 3 and 6. After I put all the points or the ordered pair on the graph, I will join the point by the straight line as we see in the graph. Let's move to slide number 4. Solving two equations of the first degree in two variables graphically. Now we will learn how to solve the two equations graphically, which means we will learn how to find the solution set graphically. We have here 3 cases. The first one, after representing the two lines on the graph, we have an intersection point between the two lines, which is x1 and y1. So the solution set will be the ordered pair x1 and y1. The second type, we have two lines coincident. What's the meaning of like congruent, on the same place? So we have an infinite number of a solution set. Every point with the two lines has an intersection point. So we have an infinite number of a solution set. The third type, we have two lines are parallel. Here we haven't any solution set. The two lines are parallel, no intersection point, which means the solution set here is phi. Let's move to slide number 5 to see the examples here. For example, I want you to see the intersection point between two lines. As we see, the first one, we have two lines. I represent the two lines on the graph. We have intersection point, which is negative 2 and negative 1. So we can say that negative 2 and negative 1 is a solution set in the first graph. Look at the second graph. We have two lines. The two lines intersected at the point 2 and 3. As I shaded kida like a circle, blue circle. So the solution set here is 2 and 3. So by graphically way, we will draw the two lines, or we will represent the two lines on the graph, then search by the intersection point of the two lines. Let's move to slide number 6. Here we have an example. L1 equal 2x minus y equals 5. L2 equal x plus 3y plus 1 equals 0. Here we have two lines. I want to represent each one by what? By at least 2 points or 3 points. As you like, you can suppose with x by 1, 2, 3, 0, 1 and negative 1. So here we have 1 and 2, 3 in x. We will calculate the value of y. We have 1 and negative 3, 2 and negative 1, 3 and 1. At the beginning, put all the points of the first line on the graph and represent the first line. Then let's represent the second line. We have x equal negative 3 minus 1. Put x by negative 1, by negative 4, by 5, or substitute in y by 0, 1, negative 2 to get any 3 points. After you have 3 points, represent the second line like as we see in our graph. Then search about the intersection point between the two lines. As we see here, the intersection point is 2 and negative 1. So 2 and negative 1 is a solution set for the two lines. Let's move to slide number 7. We have two lines. As we see, the two lines here are parallel. The two lines here are parallel. After graphing the two lines, we haven't an intersection point, as we see. So the solution set here is phi. That's because we haven't any intersection point. Let's see our example. Find the solution set of the two equations. Y equal to x minus 2, 2y minus 4, x minus 2 equals 0. At the beginning, we will represent the first line. Y equal to x minus 2 by substitution in x by points as you like. 0, 1, 2, as you like. So we have 3 ordered pair. 2 and 2, 1 and 0, 0 and negative 2. I will put all the points on the graph, then join the line. Then we have another straight line. Y equal to x plus 1. Substitute in x. 0 1 negative 1. بصوا معايا كده يا شباب، بس انا عايزه اقول بوينت معينه هنا في الجزء ده. as you like. بالنسبه لي مثلا I choose 0 1 and negative 1 in x. You can choose 2 1 3 4 as you like. Then we will represent the straight line 2x plus 1. As we see in the graph, we have two lines are parallel. That means we haven't any solution set. We haven't an intersection point. So the solution set here is phi. Let's move to slide number 9. Find the solution set of two equations. Y equal to x minus 4 and 4x equal to y plus 8. Y equal to x minus 4, I will represent the first line. Then I will represent the second line. As you see, the two lines are coincident. What's the meaning of coincident? That the two straight line on the same place. So we have here the solution set, infinite number of a solution set, or infinite number of an ordered pair. Let's move to slide number 10. We can recognize the number of solution set of any two solutions of the first degree in two variables without graphing the two equations by using the geometry, by knowing the slope of the straight line and determining the point of intersection with the y-axis as the following. Let's move to slide number 11 to see what I said. To find the slope of two straight lines, you will find the slope of the two straight lines. If the two slopes are equal, we find the points of the intersection of the two straight lines with the y-axis. If the slopes not equal, the two straight lines intersected at one point, then we say that the number of solution set equal 1. Please listen. At the beginning, you will find the slope of the two lines. If the slope of the two lines not equal, that means the two straight lines are intersected in one point. But if the two slopes are equal, we have here two ways. The 2 points, sorry. If the two slopes are equal, we have here two ways. If the slopes are equal, then the two straight lines are coincident and the number of solution set is an infinite number, where if the two straight lines intersect two different parts from the y-axis. But if the two straight lines are parallel, that means that the number of a solution set equal 0. Again, I will say this part again. If the slopes are equal, search about the intercepted part from the y-axis. If we have two different parts from the y-axis, that means the two straight lines are parallel. If we have one part or the same part from the y-axis, that means the two straight lines are coincident, which means we have an infinite number from a solution set. Let's move to slide number 12. Find the number of solution set of each pair of the following equation. We have 2x minus 3y equals 6 and y equal 2 over 3x plus 3. At the beginning, we will calculate the value of the slope m1 and m2. By using the rule we have studied in the first term, slope equal negative coefficient of x of the coefficient of y equal negative 2 over negative 3 equal 2 over 3. The slope of the second equation equals the coefficient of x equal 2 over 3. So we have here the two slopes are equal. That means we haven't one solution. We haven't one solution. The first straight line intercepted part from the y-axis at the point 0, negative 2. And the second, the intercepted part of the y-axis at the point 0 and 3. So we have here two parts from the y-axis. 3 units in the positive direction and 2 units in the negative direction. So the number of a solution set here, so the 2 point straight line are parallel because they have two parts different. Two parts are different from the y-axis, so the number of a solution set is 0. Let's move to slide number 14. Solving two equations of the first degree in two variables graphically. We will solve the two equations here graphically by using omitting method. By using omitting method, find the solution set of the solution to equation, which is 2x minus y equals 5 and x plus 3y plus 1 equals 0. We have here two equations, 2x minus 5 and x plus 3y plus 1. At the beginning, let the x and y in one side and the integers in the other side. So we have 2x minus y equal 5 and x plus 3y equal negative 1. The equation x plus 3y equal negative 1, at the beginning, I want to cancel one of the two variables. Here we have x and y. I want to cancel one of the two variables, x and y, as you like. To get the value of the second variable, to be easy to get the other variable. So negative, I will multiply the second equation by negative 2 to have negative 2x minus 6 equals y. Let's move to the next slide to see. Here we have 2x minus y equals 5 and negative 2x minus 6y equal 2. By adding, I will cancel the variable x. 2x, negative 2x equals 0. So we have negative y, negative 6y, it will be negative 7y equal 7. So y equal negative 1. So now I have the value of y. Then substitute in any equation you want or you have. 2x minus 5 equal 5. I will substitute y by negative 1. 2x plus 1 equal 5. So 2x equal, I will move 1 to the other side, it will be 5 minus 1 equal 4, then divided by 2 it will be 2. So the solution set here is 2 and negative 1, as you see. That's all, and thank you for your listening.